Hello, viewers. In today's session, we are going to discuss one very important definite integral using the concept of beta gamma functions. Right. So here we have to evaluate this integral that is from 0 to 1, and the integrand is 1 over x minus 1 raised to 1 by 6. Right. So here we'll make use of some important results from beta gamma functions. So let us start. So let us first take this integral as I, right? And here we are going to use three important results from beta gamma functions. The first one is the definition of beta function, that is beta of m comma n is given by the integral 0 to 1, and here we have t raised to m minus 1, and here we have 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So this is the important definition. And then the second result which we are going to use is the relation between beta function and the gamma function. And the relation goes like this: that is beta of m comma n is given by gamma m, then we have gamma of n divided by gamma of the sum of m and n, right? And the third, that is the most important result, which is also known as Euler's reflection formula. And the formula says that gamma of n and gamma of 1 minus n is given by pi over sine n pi, right? So these three important results will be used to evaluate this important definite integral. So let us first rearrange the terms of this integrand. That is, we can write it like this: 0 to 1, and we can take the LCM. Here we have 1 over 1, so we can write x, and then we have 1 minus x, and this is 1 over 6, right? Okay, now distributing the power, that is 1 over 6 to 1 minus x and x, we have 0 to 1, 1 minus x raised to 1 by 6, and here we have x raised to 1 by 6, right? Now taking this x raised to 1 by 6 to the numerator, we have 0 to 1, then we can write it as x raised to minus 1 over 6, and here we have 1 minus x raised to 1 over 6 dx, right? So now we have to convert this integral into this form, right? So here we have minus 1 over 6, and here we have t raised to m minus 1. So if we compare minus 1 over 6 with m minus 1, then we can write m minus 1 is equal to minus 1 over 6. So m is minus 1 over 6 plus 1. So this is minus 1, and here we have 6 over 6, so this is 5 over 6, right? So the value of m is 5 over 6, and here we have 1 minus x raised to 1 by 6, so here we have 1 minus t raised to n minus 1. So comparing the powers, we can frame an equation: n minus 1 is equal to 1 over 6. So n is 1 over 6 plus 1, that is 1 plus 6 over 6, that is 7 over 6, right? So now we have m is equal to 5 over 6, and n is equal to 7 over 6. So we can now rewrite this integral as 0 to 1, and we have x raised to 5 by 6 minus 1, and 1 minus x raised to 7 over 6 minus 1. So now this integral is similar to this one. So we can now write this integral in terms of beta function. So we have beta of m comma n. M is 5 over 6 and n is 7 over 6, right? Okay, so now the next step is to apply this result, that is relation between beta function and gamma function. So we can now write gamma of 5 over 6, then we have gamma of 7 over 6, and here we have gamma of 5 over 6 plus 7 over 6, right? Okay, so now see here 5 over 6 plus 7 over 6, it gives us 5 plus 7 is 12, 12 over 6 is 2, right? So we have gamma of 2 in the denominator, and gamma of 2 is given by 1 factorial, that is equal to 1, right? So now we are left with I is equal to gamma of 5 over 6, and here we have gamma of 7 over 6 because the denominator is equal to 1. So now we have to express this gamma of 7 over 6. Then we can use this result, that is gamma of n plus 1 is also equal to n times gamma of n, right? Where n is some fraction. So here we have 7 over 6. So we can now write gamma of 5 over 6, then gamma of 1 plus 1 over 6. So this is n plus 1. So this is our n here. So we can now write it as gamma of 7 by 6 can be written as gamma of 1 over 6 plus 1, that is equal to 1 over 6 times gamma of 1 over 6, right? So now we have here gamma of 5 over 6 times 1 over 6 and gamma of 1 over 6, right? So now we can combine these two expressions. So now I can be written as 1 over 6 times we have gamma of 1 over 6 and gamma of 5 over 6. So now here we have to make use of Euler's reflection formula. So now I can be written as 1 over 6, and here we have gamma of 1 over 6, and gamma of 5 over 6 can be written as 1 minus 1 over 6, because 1 minus 1 over 6 is 5 over 6, right? So now this expression is similar to this one, gamma of n times gamma of 1 minus n. So our n is 1 over 6, and this expression is equal to pi divided by sine n pi. So we have I is equal to 1 over 6, and here we have pi over sine of n pi. N is 1 over 6, so we have pi over 6. So this is 1 over 6, and sine pi by 6 is sine 30 degrees, which is equal to 1 over 2, right? So taking this 2 to the numerator, we have 2 pi divided by 6, right? And here we have 2 times 3 is 6. So this is equal to pi over 3. So viewers, the value of this integral I is equal to pi over 3. So this is how, by making use of the concept of beta and gamma functions, we can evaluate these kind of integrals.